Okay, in this question we're going to compare two models, a frictionless model against a friction model. The whole question is here, but I split the question into two parts. So if you want to read the whole question, just pause the video now. Okay, it says a block of mass 2 kilograms has been pulled up a plane inclined at 30 degrees to the horizontal by a force of 12 newtons. The block has an initial velocity of 1.6 meters per second up the plane. Two models for the block's motion are proposed. In model A, the plane is taken as smooth. It says calculate the time the model A predicts the block to slide up the first 0.8 meters and explain why model A is likely to underestimate the time taken. Okay, so what you should do is draw a diagram, obviously. Okay, so the forces acting on the block will be its weight acting downwards, which is 2g. There will be a normal reaction and the force of 12 newtons. There's no friction because the plane is smooth. Okay, we have an acceleration, and if we resolve along the plane, and because it's an acceleration we use Newton's second law, so we'll have 12, and then there'll be this component here of the weight, which is 2g sine of 30, is equal to mass times acceleration, so it'll be 2a. And then from that, we can calculate that A is 12 minus 2g over sine 30 divided by 2, which gives an answer of 1.1 meters per second squared. Right, in order to calculate the time to move up 0.8 meters, as the acceleration is constant, we can use the Suvat equation. So we're going to use S is equal to ut plus a half at squared, where u is the initial velocity of 1.6 meters per second. So we're going to have that 0.8 is equal to 1.6t plus a half times 1.1t squared. So it's going to, if we simplify that, we're going to get 0.55t squared plus 1.6t minus 0.8 is equal to 0. Then if we use our calculator solver, we're going to get that t is 0.4349, or t is equal to minus 3.344, which is a meaningless answer, just not possible. We can't go back in time yet. Okay, so we're going to have t is equal to 0.435. Why is this an overestimate? Well, model A does not take into account air resistance or friction, which will reduce the acceleration and therefore increase the time. Right, model B. In model B, the plane is taken as rough with a constant coefficient of friction between the block and the plane. Calculate the acceleration of the block by model B. It takes 0.6 seconds to slide up the first 1.1 meters and find the coefficient of friction predicted by model B, given your answer correct to 3 significant figures. So, again, a diagram. So the same diagram, the same forces acting on. This time we're going to have one extra force. As it's moving up the plane, there will be friction acting down the slope, which will be mu times r. And we need to remember the initial velocity is 1.6 meters per second from the main body of the question. So using again S is equal to ut plus a half at squared to calculate the acceleration, we've got 1.1 is equal to 1.6 times 0.6 plus a half times acceleration times 0.6 squared. So rearranging that, we're going to have that A is 1.1 minus 1.6 times 0.6 divided by 0.5 times 0.6 squared. And that will give an answer of 0.77 recurring meters per second, which is 0.778 meters per second, correct for 3 significant figures. Right, we will now find the coefficient of friction. So just drawing out the diagram, you wouldn't have to draw it again in the exam. So if we resolve perpendicular to the plane, so this way, we're going to have the r minus the component of the weight here, which is 2g cos 30 is equal to 0. There's no acceleration going that way. So R will be 2g cos 30. So if we're resolving along the plane, this way, we will now have 12 minus the component of the weight here, which is 2g sine 30, minus mu times 2g cos 30. So that's mu R, this force here, is equal to the mass times the acceleration we just calculated. So we need to find mu. So rearranging that a little bit. So bringing this over here and this over there. And then to find mu, we need to take this and divide it by 2g cos 30. Okay, again, I calculate out, use the fraction button, make sure your calculator is in degree mode. And we get an answer of 0.0379, which is 0.03802. 3 significant figures. Okay, this has been a video to show you how to compare a frictionless model against a friction model. I hope you've understood, and I thank you very much for watching.